Basic Chemistry by Karen Timberlake, Section 6.2 on ionic compounds. So if you remember that the octet rule is kind of the driver of the ship in terms of chemistry, just like gravity is the driver of a ship of rocks falling down hills. So an element will react with another element or with itself in order for each of those atoms to have a configuration that would be the same as a noble gas configuration. And that would be that the very last shell of electrons would have 8 in them. That's the octet rule. So 8 valence electrons is stable. Okay, just like rocks at the bottom of the hill are stable, rocks on the top of the hill are unstable. I don't mind bricks on the ground. I don't like bricks on tops of buildings because they could fall on my head. So it's the same idea with chemistry. You will either steal electrons from each other in order to get 8, or you will share electrons with each other in order to have 8. In this section, we're going to look at ionic compounds, which are ions, and ions are made when you lose electrons or gain electrons. So if you steal electrons, you become negative, and that would be called an anion. If you gain electrons, if you lose electrons, then you are a positive and you are a cation. Once you have a positive and negative charge, they stick together just by static electricity. It's an electrical connection or electrical force that's pulling these two things together, and that's the bond. Okay, so let's look at some examples. So this says ionic compounds consist of positives and negative ions. Once you have a positive and once you have a negative, those positives and negatives will attract electrically. It's an electrical attraction. So they're charges. Opposite charges attract each other, like charges repel each other, and there's actually a force, an electric force that will either attract or repel. The ionic bond is that attractive quality, that static electricity, that static quality, just like socks stick together in the dryer because one of those socks is positive charge, the other socks is negative. A couple things I'd like you to add that you may not be able to guess. Ionic compounds have very high melting points and very high boiling points. The reason why is because if you are going to boil, you want to get away from the other things that are in the liquid. Okay, and if you're attracted to the other molecules in the liquid, then you don't want to become a gas. You stay in the liquid. So a high boiling point is something to where there's a pull that wants to keep it as a liquid, or a pull in terms of solid. It wants to keep towards the other things, and it doesn't want to melt. So these charges are holding it in to, say, the salt or to the liquid salt. It would be very, very hot, but you could melt salt, and I suppose you could boil salt if you had extremely high temperatures. Okay, put something in the middle of the sun, see if it melts. So high temperatures are high boiling point, high melting point, because they're so sticky to each other. They don't want to separate, and they are all solids at room temperatures. Okay, I would also call these many times salts. Now, you know that sodium chloride is table salt, but there are thousands of salts. And these salts, I think of ionic compounds as salts. There's more specific definitions as we go further, but that's a good kind of thing to keep in the back of your mind. So here's that example. Salt is an ionic compound. Sodium chloride, I explained to you that sodium is a metal. It's gray, cream cheese consistency, blows up in water. Chlorine is a gas, green, poisonous. When they combine with each other, they make sodium chloride, and sodium chloride is going to be a crystal. And you've seen a crystal of salt. It has a definite crystalline shape to it. This one happens to be cubic, but it is where the positives and negatives are all intertwined, all holding onto each other. An ionic formula is not really a molecule. When you say I have a molecule of water, I have one molecule with two hydrogens and one oxygen combined together. We're going to see later that those are covalently bonded. They share electrons. And a molecule is a distinct something. Like you could count them. You could say, here's a molecule, here's a molecule, here's a molecule. If you had a good enough microscope, I guess. When you're in ionic formulas, it doesn't really exist that way because you end up with a positive beside a negative, beside a positive, beside a negative, beside a positive. And so, for instance, a salt crystal isn't like a water molecule is microscopic, but a salt crystal could be as big as a mountain because a salt crystal is as many positives, negatives, all sitting beside each other, all in a matrix, three-dimensionally, negative, positive. And so it's not really called a molecule, it's called a formula unit. So if you have NaCl, that means in salt, for every chlorine you're going to have one sodium. You'll have one positive sodium beside one negative chlorine, positive, negative, positive, negative, positive, negative. And then the crystal of salt is as big as you want it to be. You could have it very, very small, or you could have it very, very big. You could take a grain of salt, press it with the back of a spoon and make it into dust, break it into dust. All that dust is salty. Okay, if you were to just put that dust on your tongue, it would taste salty. Okay, a crystal is just a huge amount of the positives and negatives together. In an ionic formula, since you have the same number of positives and negatives, it's neutral. So this is not an ion. This is the ion. The ion is the positive particle and the negative particle coming together. And then once you have that, it's neutral. It's no longer positive, no longer negative, because the positive and negative cancel each other out. So you have to realize, and you can please put this in your notes, that they all add up to zero. So all the positives you have in salt and all the negatives you would have in salt would all be equal, and so the positive and negative cancel each other out. And so NaCl, sodium chloride, doesn't have a charge. It's neutral because the sodiums, which are positive, and the chlorines, which are negatives, come together and cancel each other out. The subscripts, that's meaning you write a little number underneath the symbol, will tell you how many of each that you have in that combination. And we'll look at that in a second. Okay, so here's the first combination, NaCl. So that you don't need a 1 and a 1 because it's just assumed that if you've got Na, you've got one Na. Cl, you've got one Cl. So one atom of sodium is on the left, and you remember the left becomes positively charged. The chlorine, which is in group 7, is on the right. It wants 8 because it wants to be like the group 8. So it steals an electron from the sodium, from the outer shell of the sodium. Since the outer shell of the sodium only has one electron in it, as soon as you steal that electron, you've stolen the entire shell. Well, the inside shell, which was full, now becomes the outside shell. And so it's stable because the outside shell has 8 in it. In the chlorine, now it's no longer sodium metal, it's sodium ion, so it's Na+, okay, because it's lost an electron. The chlorine gained an electron, and now it's stable. It's like it doesn't have 7 electrons in its valence shell. It has 8, so it's stable. It has 8 like a noble gas, but it's no longer neutral because I have one extra electron than I did, and so I have an anion. I have a negative ion. So the sodium is a positive ion, Na+. The chlorine is a negative ion, Cl-. Once you have a positive and negative, they stick together just like socks in the dryer. So the charge balance in NaF. So we've got sodium fluoride. Fluoride is also in group 7, just like chlorine was. So it wants to steal 1. So it steals 1 from sodium. Okay, so now sodium That last shell is now gone. The inside shell was full, and now it's the outside shell. So it's stable. The sodium ion is stable, but it's in a plus. The fluorine had 7. It stole 1. Now it has 8. So it's stable, but it's no longer neutral. It's now 1 extra negative, so it's minus. So you have Na plus, F minus, but when they come together, the plus and the minus cancel each other out, and you just have NaF, sodium fluoride. So when you take the positive 1 and the negative 1 together, its charge now is 0. So it has an overall charge of 0. All right, now in this case, we don't have 1-to-1. Magnesium is in group 2. All right, let's do some review. In group 1, it becomes positive 1. Group 2 becomes positive 2. Group 3 becomes positive 3. Go over to group 7. Group 7 becomes negative 1. Group 6 becomes negative 2. Group 5 becomes negative 3. So if magnesium is positive 2, how many negative 2's or how many negatives do I need to balance? Do you see? I need a negative 2 to balance with my positive 2. In order to get it 0, it has to cancel. So how many chlorines do I need? Okay, we have to ask ourselves, what is chlorine? Chlorine's in group 7. That means it's negative 1. So I need how many negative 1's to balance with a positive 2? Okay, that's how you talk to yourself. You think it through. I have a positive 2. I have 2 negative 1's. Does that balance? 2 negative 1's is negative 2. 1 positive 2 is positive 2. A positive 2 and a negative 2 cancel. And as long as I get down to a 0 charge, that makes the formula unit, or that is the compound that I have. So magnesium chloride would be MgCl2. What if I changed chlorine for fluorine? What would its formula be? Fluorine is in group 7, just like chlorine, so it'd have to be MgF2. Okay? So that's how you start thinking. Where is it? What charge does it make? Now do I need more than one of them in order to balance with the other? All right, here's one where the positive has to double. Sulfur is in group 6. So what's its charge? Okay, group 7 is negative 1. Group 6 is negative 2. All right, so the sulfur is negative 2. How much positive do I need to balance with negative 2? I need a positive 2. All right, so if I'm going to use sodium, sodium is in group 1. So what's its oxidation number? Positive 1. So how many positive 1's do I need to balance with a negative 2? I have to have 2 1's to balance with a negative 2, and so I have 2 NA's and 1 S, and put it together, I'll have Na2S. I really think that some of you right now got an I get it. That should have been enough. Please, if you did not do a ding, if your head didn't ding, could you go back a few minutes and do this again and see if that clicks to you. Your formulas are based upon how many of each do I need. If I'm going to combine sodium and sulfur, what do they fit in? How many do I need of this to fit with a this? All right, that's how you do it. All right, so writing the formula, writing in charge. So here's a sodium and nitrogen. What nitrogen's in group 5? So let's do it again. Group 7 is negative 1. Group 6 is negative 2. Group 5 is negative 3. So if I have a negative 3 and I'm combining with sodium, all right, sodium is in group 1, so it's a positive 1. How many positive 1's do I need to balance with a negative 3? I need 3 positive 1's to balance with 1 negative 3, and so I need Na3N. Okay, that should have been a practice. If you understood it previously, you should have been able to do that one. Okay. Write the ionic formula of a compound containing barium and chloride. And they gave you the charge here. Barium is in group 2, it's positive 2. Chlorine is in group 7, it's negative 1. So put them together. How many of the how many of the smaller number, do you need to balance with a bigger number? Okay, so which one is the bigger number? In this case, it's the positive. I have a positive 2. Now, the smaller number is a 1. How many 1s do I need to balance with a 2? I need 2 1s. So I need 2 chlorines. So my formula would be BaCl2. I would love to be able to see your face to see if this makes any sense for you. Let's do a little bit of review. Select the correct formula for each of the following ionic compounds: Li and O2. Li positive, O2 negative. All right, so which one is the bigger number? The 2 negative. What's the other one? A 1. So your question is, how many 1s fit in a 2? And you'll have to say 2. I need 2 1s. So whatever the smaller is, that has to have the subscript. So it would be Li2O. Li2O. B. Aluminum, which is 3 plus, and chlorine, which is 1 minus. All right, which is the biggest? Aluminum. Okay, so that's a 3. The chlorine is a 1. How many 1s fit in a 3? 3. Where does the subscript go? On the small one. So the chlorine gets the subscript. So how many? 3, because it takes 3 1s to make into a 3. So you're going to have AlCl3. Last one, magnesium, which is a 2, and nitrogen, which is a 3. And this is mean, okay? This is, your mean 5th grade teacher would have done this to you, I'm sure. I need a common denominator between 2 and 3, okay? How many do I need? Well, I can't say that 2 fits into 3 because 2 fits into 3 3/4 of a time, or 2/3 of a time. So it can't be that way. So I'm going to have a common denominator between, or a common multiple between 2 and 3, which is 6, right? So in order to get 6, 2 times what is 6? And 3 times what is 6? Okay. 2 times 3 is 6. 3 times 2 is 6. So magnesium, I need a 3 to make a 6. So 2 plus times 3 would be 6 plus. Okay, so it would be magnesium 3, Mg3. The nitrogen, 3 times what equals 6 is 2. So it needs to be N2. So this would be Mg3N2. Okay, if I were still doing tests with you, that would be on the test, at least one of those, because you have to switch it. Now, if you see that the 2 on the magnesium is on the top and the 3 on the nitrogen is on the top, switch them. Take the 3 and put it from the top of the N down to the bottom of the G. Do you see? Look at the C, Mg2 plus and N3 minus, and now look at number 3, Mg3N2. The 3 on top of the N goes to the bottom of Mg, and the 2, which is on the top of Mg, goes to the bottom of the N. That's a cheat way to do it, okay? But it works. That way you're not thinking I need a common multiple between 2 and 3. The 3 goes down to the Mg, and it becomes Mg3. The 2 goes over to the N, and it becomes N2. But that's really what you're doing. You're making a common multiple. Okay, I hope it makes sense to you.